Hi, I'm Smita Pendharkar from Pendharkar's Coaching Institute. You can download our app, that's Pendharkar's Coaching Institute app. Check out the store for Performance Booster Pack, where you'll be finding very useful videos. And I'm now proceeding with one more such video. So let's understand how to obtain this half angle formulae. Half angle formulae we have done in 11th standard also, but this half angle formula, it's specifically when you have in triangle ABC. So this I have mentioned earlier also. We are dealing with trigonometric equation chapter, in which there are subtopics. So in that solving triangle, that section we are dealing with. So triangle we are supposed to solve, so obviously in triangle ABC should be there. So you can use these formulae only if in triangle ABC is mentioned. Otherwise, we cannot use this formula. So this is specifically for in triangle ABC. So 11th standard mein half angle formula which we had learned, that was applicable in general. It is not only for triangle, it is for the triangle as well as in general we can apply it anywhere, provided angle is there. So here, in addition, one more term which we are learning is small letter s. The small letter s stands for semi-perimeter. So perimeter is sum total of the boundaries. So semi-perimeter will be half of that. So we'll be deriving some new half angle formulae in terms of these, in terms of this semi-perimeter S. So here the formulae are written for angle A in the half angle form, that's A by 2. So sine A by 2, cos A by 2, tan A by 2 we have to derive. So let's start with the working. Once we understand the working for this, similar we can apply the logic for finding the formula for angle B by 2 and angle C by 2 also. So here first we'll use the normal trigonometric formula where half angle we have learned. So I need sine A by 2. So sine A by 2 comes in the expansion of 1 minus cos A. 1 minus cos A is nothing but 2 sine square A by 2. Now what we can do is we can shift this 2 onto the left hand side, take out the square root. That can be done, or we'll just try to simplify and see whether we can cancel off 2 from both the side and then take out the square root, so that we are not disturbing this 2 sine square A by 2, keeping it as it is. We have also learned cosine rule, so that is applied over here. Cosine rule is nothing but b square plus c square minus a square, the whole thing upon 2 times of bc. Once again, it follows cyclic order. Here it is for a, so after a follows b. So here we have the sides, b square plus c square minus a square, the whole thing upon 2 times of bc. This is cosine rule for cos a. We'll take the LCM over here. So 2bc multiplied with 1, open the bracket. After this, the next step is what we observe over here. If we take out negative sign common from these three terms, so a square is undisturbed, it is written first, a square minus of b square plus c square minus of 2bc. So negative sign is taken common from these three terms, and here we can use the formula a plus b the whole bracket square, sorry, a minus b the whole bracket square. So doing that, we can reduce this entire arrangement into b minus c the whole bracket square upon 2bc we are getting. Next step, this is of the type now x square minus y square. X square minus y square is nothing but x minus y, x plus y. So we are using that formula. So a minus of b minus c into a plus of b minus c upon 2bc. This is what you have got. Next, what is to be done is we will try to, all the formulae which are to be derived, it needs the presence of S. S is nothing but semi-perimeter. So semi-perimeter is nothing but A plus B plus C, it's equal to 2S. Semi-perimeter, we can take it as A plus B plus C upon 2 equals to S, or A plus B plus C is equal to 2S. We can consider this way also. Okay. So what is done over here is, in this first bracket, what we're getting is A minus B plus C. So A plus C is present. So I need A plus B plus C. So positive A, positive C is present. What is missing is positive B is missing. So in the first bracket, positive B is introduced. You add b and you subtract b. So 1 minus b is already there. One more minus b is introduced, so it becomes minus 2b. Same way over here. A plus B minus C is there. So A and B are present. What is missing is C. So your C is added as well as subtracted. So you get A plus B plus C minus 2C. Add and subtract C over here. Add and subtract B over here. So this A plus B plus C, which is there, it can be replaced by 2S in both the places. Then we can take out 2 common from each of the bracket. So once you take out a 2 common from here, we can cancel that with the denominator, and second 2 which taken out common can be cancelled with the right hand side. So there are no more 2 left. What we have is s minus b, s minus c upon bc, and on the right hand side sine square a by 2. Now we'll take out the square root. So once we take out the square root, we get a required expansion or equation completed. So sine a by 2 equals to root of s minus b, s minus c upon bc. So this is the formula. So here how we had learned this formula was here for sine a by 2 expansion. In this square root, there is no a present. Side a is not present. It is in terms of b, c and s. In the numerator s minus b, s minus c. In the denominator b, c product. Same way we can derive for cos a by 2. So for cos a by 2, we'll use the formula 1 plus cos a, which is nothing but 2 cos square a by 2. Again, we'll use the formula of cosine over here, cos a. Then again take the LCM. Now there is no need to take out a negative common because all three are already in the positive form. So we can reduce this to b plus e the whole bracket square. Here we'll use again x square minus y square. So it will be x plus y, x minus y. Again, we'll try to bring 2s over here, which is nothing but a plus b plus c. So the first bracket is already a plus b plus c. We can replace this by 2s. Here b plus c is introduced, a is missing, so add and subtract a. So it will become 2s minus 2a. Then again take out 2 common, which will get cancelled off. So what will be left with is s minus a upon bc. So this is the formula for cos of a by 2. So in cos a by 2, square root is coming. In the denominator bc is there, but in the numerator b and c are not there. It is having s and s minus a. So that is the difference in the formula of sine a by 2 and cos a by 2. Both of will have the same denominator bc, but in the numerator they will have different terms. So sine a by 2 had s minus b, s minus c. Cos a by 2 is having s minus a. So four terms are there: s minus a, s minus b, s minus c, which is distributed in cos and sine term. Once this is done, tan expansion is the easiest because tan is not derived. It is taken as a ratio of sine a by 2 by cos a by 2. So sine a by 2 is square root of s minus b, s minus a upon bc. Cos a by 2 is s minus a upon bc. Bc will get cancelled. So what we are left with is the ratio, which is the formula of tan a by 2, that is root of s minus b, s minus c upon s minus a. In the same way, we can extend this and obtain the formula for sine b by 2, sine c by 2, cos b by 2, cos c by 2, and then tan b by 2 and tan c by 2. So we can obtain the corresponding formula. So this is the half angle formula where semi-perimeter is introduced, and these formulae are applicable only when we have in the question in triangle ABC. Otherwise, we cannot use this formula.